what we have discussed up to now is the type of data we have, the measurement scales, and so on and so forth. Okay. And wherever in the slides, if we are talking about CE, that means civil engineering, okay? So there was one thing mentioned earlier, which I forgot. Yes, most of the CE data is the ratio data, okay? Then stress, force, strength, mass, time. Okay, so moving on. Yeah. Okay, so you can now this code is there in the slides. Okay, so you can copy this as it is and run it. Okay, it will create a data structure for you. Okay, and that data structure will be composed of a set of vectors. Okay, and you can see which one of them is what. You can just copy and paste, no problem. Studio. Nulva.
Yeah.
Studio.
Studio, yeah.
And then we have the concrete type. Okay, we have NC and HPC. Okay, these are the type of concrete. What does it mean?
Which one?
NC and HPC. Anyone? NC is C is concrete, right?
Yes.
Type of concrete. So C is concrete.
No.
N is normal, and HP is
High performance.
high performance. Okay, and then these are the values of the strength of each of them, and they have a one-to-one link mapping. For sample type of concrete, and first value of this concrete. Sorry.
I got this.
What is it? Yeah. So it's a vector, right? It created a table for you.
Yeah.
Okay, and you can see the file there. My data.
Yeah, I can.
There.
I can buy something.
Sorry.
What is this?
Which one? My data.
So this is the data I can.
Yeah. So it's telling you about the type of data you have.
Arranged.
This is the arranged data. This is like what you have. So concrete type, what is it?
Yeah.
It's character data. Okay, it ranges from 1 to 4 characters. And the second one is also character data. Okay. Yeah. And the strength, so it has ordered it into alphabetical, because you see ID is the first one. Then the third one is numeric data. So you can see number here. Okay.
How to open?
Table.
This one. Click this one. My data.
Okay. How many videos? Free? Okay. So it tells you, you can see the values, it tells you the structure of the values. Okay. You can see the template format, you can see the details as well. Okay. And as I said, this should be in a file in your PC where you have the R Studio or R. Is it showing here? Is it showing here? No. No, right? But in your
Which one? Studio?
no, it has my data is created with the file in your PC. Is what I'm saying.
Maybe
It must be in the R folder something.
if it's not saved or.
No, it's already saved. It's already saved. When you created it, it's saved in the default folder.
Yeah.
No, my data is my underscore data. because when you want to run it, when you have your own data, you want to run it on R, it will take the default folder from where it will take the data as well.
This is the last one I did. It's artist too.
Okay, but as far as the language goes, okay, so this is when you're creating the vectors, okay, so this is the name of the vector. This is like the assignment statement, okay, and this is the assignment symbol. So this will be stored here, okay, and if what you are putting here is not non-numeric, then you have to use it to commas, and it will go one by one, okay. And if you want to combine it, okay, this is how you combine it: data frame statement, and this is just the name of the file. My data is just the name of the file, okay, and this is the statement to combine the data. And you can see, then you just write down the IDs with a comma. Very simple, right?
So
You want to view it, then you view it here. Like, want to view it, you just put the name and it will appear. Let me check. Clear? Okay. Now this one is nominal data because this is type of concrete. This one is ratio data. Okay. And what about this one? This one, the first one. So what data is it? We don't care. We don't care. Okay? It has nothing. It has nothing to do with, ID has nothing to do with my analysis. I will not even use it. Okay? Again, just for the sake of cross-referencing. This is my sample 1, the sample 2, and so on. Okay, so if you want, after you have done this, you can get the structure of the data using this command, but I believe it will show the same thing which you saw earlier. Same, right? Or something else?
So show like this structure.
Okay. Same thing which you see in the side window. Same thing. Okay. If you want to get the summary of the data, the command is summary. Okay. So you can do summary, and it will give you the summary of the data.
So it will give us the mean, median.
Yeah.
Maximum.
Okay. Is it giving it for all? Only strength, right?
Yeah.
For others, it's not possible.
Because
Okay. So for specimen ID, it's just telling you the class and mode. Okay. And for concrete type,
is
same.
4, so 4 types.
Not 4 types, length of the
Number of
digits.
types.
Okay.
So number
Length of the size of the
sample.
length
Means number of types, which is
number. Okay. Fine.
or some sampling number. Sample.
Sample. Okay. If you want to see, so my data has 3 variables. You want to see a particular column from there, you can use it with the $sign. So my data, the variable which you want to see, and it will only show you for that variable. Okay, so you can do summary. Now you are doing summary my data. You can do summary my data $only strength, and it will give you only for the strength. Okay, and then there is a mean command as well. So you want to calculate the mean of strength only, so you will do mean my data $strength. It will only give you the mean.
Which is already the same as this because.
Sorry.
Which is already the same as the mean here because we only have.
Yeah. Just.
But this only have one name, which is for this thread. But
Yes.
if we had another column, for example, and something else, we can use this to specify which name we want.
Yes, yes. Okay, clear? Okay, then we have the sampling design. Up till now we have talked about variables and their measurements and scales and the type. Now we are going towards number of samples. Okay, sampling design is a very important aspect of research. So the idea behind doing the sampling is you cannot test the entire population of your product, your item. I cannot test all possible samples of concrete. I cannot test all possible samples of steel. So I have to collect a sample. Okay. And even if I am talking about just one bridge, I cannot test all the bolts which are in one steel bridge. There will be hundreds of them, right? Okay. I cannot check each cubic meter of concrete. Okay. If I am going to pour concrete, you must have seen on the sites now. Okay. So they take a sample, right? Although they are producing that entire cement, entire concrete themselves, but still they cannot test all of it. Okay. Because then it will be wasted. So we have two different methods of selecting the samples. One is called as probability sampling, the other one is called as non-probability sampling. Probability sampling is something which we consider as generalizable, okay, which others can follow exactly. Okay, so if I say I took, for example, is it mentioned here? No. Okay, so if I tell someone that I took every 5th sample for my testing, anybody can follow it, right? I'm giving the exact method of my sampling. So that is probability sampling, and the good thing is people can generalize it. It can be simple random sampling, or it can be stratified sampling. Okay, so in simple random sampling, for example, you put all, you have 10 people in the class or 100 people in the class, and you put all their names in one place and then you pick. Okay, so there is a possibility of any name coming out, right? It's random. Okay, and there are methods to do random sampling through software as well. Okay, so each time I don't have to choose myself. The software can do it for me. And then we have stratified sampling, where you are choosing randomly but from groups of observations. Okay, so I put, yes, I have 100 students, I put all their names, but now I know some of these students are from structures specialization, and some of them are from transportation specialization. Okay, so I am choosing, but I am choosing from each group, not from total. So in random sampling, all the groups are combined together. In stratified sampling, these groups are divided. Okay, and I'm choosing randomly but from each group. Okay, and this makes sure that all groups are represented. All groups are represented. I just give the example of the solar cell data we are working on, right? And he was saying some molecules are like this, some are like this. Okay, and this was exactly his point. I was doing sampling. Okay, we have around 12,000 values, more than 12,000, almost 13,000 values. And I was doing sampling, I was doing random sampling. So he told me, maybe your random sample does not have this alignment at all. It can happen, right? Yeah. Okay, a random sample can end up with all values from the same group randomly. It can happen, there is a possibility. Very low possibility, but there is, right? Yeah. Okay, so that's why sometimes random sampling is not considered useful. So then we go for stratified sampling. So we take samples from each group. For example, you have different types of bridges. So instead of taking samples randomly from any bridge, you say, okay, from each type of bridge I will take 5 samples. So that means each type is represented at least 5 times. But within each type I am splitting randomly. Got it? So this is called as probability sampling. Why it is called probability sampling? Because the chance of any name I am picking from the list is random. Okay, and it's random according to the probability. Okay, anybody can come and calculate the probability of my name being picked from the list and your name being picked from the list. Okay, and same thing with the groups as well. Then we have non-probability sampling. Okay, which is exploratory. So it's according to your situation. Okay, so I look at, okay, I will go there and then I see that I have this thing, and then I try to manage my samples according to that. Okay, so one is called convenience sampling, the other one is called purposive sampling. In convenience sampling, whatever you can get easily. I am not looking at all the students. I am from transportation. I'll pick the students from transportation. Okay, more convenient for me. So you both get out. Okay, but it happens a lot when you are doing the survey. Have you done any surveys in undergrad or anywhere? Okay, you do, right? How do you do it? Google form. Who will use Google form? Who will use Google form? Everyone? If I go outside and ask a cleaner.
Students.
Okay, and where do you send it?
University groups section.
This is what now?
This is a convenience.
Convenience. Okay. Then if I am going for probability sampling, then I should take from everyone. Okay, so this is called convenience sampling, and then purposive is that who are the people who will be more affected by my experiments, or who will be having more impact on my
So my audience.
data. Huh?
Audience basically.
Yeah, audience. You select your audience. You select your audience according to your purpose. Okay. The most common thing in this is we call it focus groups. Okay. So for example, I want to do a survey which is related to metro. Okay. If I do it for everybody doesn't know about metro. They don't know when it will happen. They don't know what is happening in metro. Okay. So what I will do, I will go only to people who can give me the right answer. Okay. So I will go in the Ministry of Transportation, Ministry of Works. That's it. Or maybe Traffic Directorate. Okay. So I am selecting my samples based on my purpose. Okay. Who will best serve my purpose? But I am doing it in advance. Okay. You may have seen some surveys where they will ask some questions at the start. Okay. Are you a Bahraini? Yes. Go ahead. Non-Bahraini? Okay. Okay. Thank you very much. And so on. Okay. So this is purposive because the other questions are related to only Bahrainis. Got my point? Okay. So these are both exploratory. They are situation based. Anybody else comes and tries to adopt the same methodology as yours, he may end up with a completely different sample. Okay. So what you are doing with your Google form, if I do it, I will not find the same sample because my groups are not university students. That no one? Okay. And same thing with the purposive as well. I am doing for metro and you are doing for new reinforcement in cement, concrete. So my sample will be different. I will choose different type of people and you will choose different type of people. Okay. So that's why it's non-probability and it is exploratory and largely non-generalizable. Okay. For example, if you are assessing concrete strength in a building, okay, you may use stratified sampling, okay, and you may take samples, some samples from columns, some from beams, some from slab, some from footing. Because in this case, if you apply random sampling, then we know that the strength requirements for beam are different than the strength requirements for slab. Okay, and then you will do what? You will mix everything up. You get my point? Okay, so you may not have the true representation of the strength of concrete you have. Okay, for example, you need to assess the corrosion level of rebar, reinforcement bars, which in a 50-year-old 2-kilometer long seawall. Okay, so I want to see the corrosion level in steel bars. The bridge is 50-year-old and it is 2 kilometers long. Okay, and it's like a sea wall, so it's beside the sea. Okay, what sampling strategy would you propose? What is your population? What is your sampling unit? And which technique would you use and why? Yes, and we have to think about cost and accuracy. You can discuss with each other. You can come up with a plan and we can discuss. You do understand that you can increase the accuracy, but it will have some cost, and vice versa. You can compromise on the accuracy with less cost. So think about that when you are making up when you are answering these questions. Go ahead. Okay. So this is now homework 2 for your thesis topic. You have to identify at least 2. Now, obviously, you will move on and make it a proposal, right? Later on. Okay. So it can be more than 2. It can be more than 2. Okay. But 2, like, yes. Good. Yeah. So 2 independent variables and 2 dependent variables. Okay. And you classify their measurement scale, nominal, ordinal. Okay. You will propose a sampling strategy for your study. Okay. And you will justify your choice. Okay. And propose a sample size. Propose a sample size. Right now we don't have that. We have not done calculations yet. Okay. But you can look. Okay. There's a file uploaded on Blackboard. Okay. It has concrete strength values. Okay. Like, so complete data set. Okay. It has variables on it. So you can use a structure command and summary command to explore this data. What type of variables we have, what is the mean, maximum, minimum. It's just for the sake of practicing the R software. Okay. And once you have it, you can write something about each variable yourself. Looking at what the software is telling you, you can write something about it yourself. So every variable, there is a sentence. Okay, a statement from your side. Okay.
Doctor, for the homeworks, do we have to submit separate files for homework 1 and 2?
Up to you. Up to you. If you are putting in one file, then make sure that there's some sort of heading or separation.
For each.
Yeah, divided. Okay. If you want to submit separate files, I don't know. If you make it one submission, I believe it will take it. But I did not make multiple submissions. But don't do multiple submissions, please. Even if it allows. But then I have to go to one and then. Oh, you are only 2, I can do it, no problem. Do whatever is convenient, no problem. But I believe multiple submissions, I do not do it. Okay. So the next topic which we will start will have descriptive statistics and data visualization. Okay. So right now we have tried to understood the data. Next step will be the very, very, very basic analysis which we can do with this data. Okay. Interpretation of the data with some very basic analysis. Like you are doing interpretation right now. Okay. The scale, the type of data you have, secondary, primary. This is also interpretation of the data. But now we will do the interpretation using some very basic analysis techniques, and we will focus on descriptive analysis and some graphical results or something. Okay. Okay. If you want to, so for some reason, I don't know, if you are mad enough, you can go through these things. Okay. Data set, I already told you, it's part of the homework. You should go through it. It is comparing between 2 different concrete mix designs. It's good data, okay? It's good and it's real. It's not made up. It's real data, okay? And this is ASTM, which tells you about the sampling of materials. So I think it is mentioned in some other slides as well. So have a look at it, download it. It may help you later on when you are doing your thesis studies and so on. Okay.